8286 microprocessor is a 16-bit microprocessor that has the ability to execute 16-bit instruction at a time. It has non-multiplexed data and address bus. The size of the data bus is 16-bit, whereas the size of the address bus is 24-bit. It was invented in February 1982 by Intel. 8286 microprocessor was basically an advancement of 8086 microprocessor. Further, in 1985, Intel produced upgraded version of 8286 which was a 32-bit microprocessor. Now, the question arises, what are the factors that make 8286 more advantageous than 8086 microprocessor? Let us see. The salient features of 8286 microprocessor are: it has non-multiplexed address and data bus that reduces operational speed. The address memory in case of 8286 is 16 MB. It offers an additional adder for address calculation. 8286 has faster multipliers that leads to quick operation. They perform per clock cycle of 2086 is almost twice when compared with 8086 or 8088. High performance microprocessors with memory management and protection. 8286 is the first member of the family of advanced microprocessor with built-in on-chip memory management and protection abilities primarily designed for multi-user multitasking systems. It is available in 8 MHz, 10 MHz and 12.5 MHz clock frequencies. The 8286 CPU with its 24-bit address bus is able to address 16 MB of physical memory and 1 GB of virtual memory for each task. The table shows the comparison of 8286 among some other microprocessors of Intel family. The 8086 microprocessor has a data bus of 16, an address bus width of 20 and memory size of 1 MB, whereas 8286 has a data bus width of 16, address bus width of 24 and memory size of 16 MB. Let us discuss about the operating modes of 8286 microprocessor. The 8286 microprocessor operates in two modes, real address mode and protected virtual address mode. In real address mode, this microprocessor acts as a version of 8086 which is quite faster. Also, without any special modifications, the instruction programmed for 8086 can be executed in 8286. It offers memory addressability of 1 MB of physical memory. The protected virtual address mode of 8286 supports multitasking because multiple programs can be executed using virtual memory. This mode of 8286 offers memory addressability of 16 MB of physical memory along with 1 GB of virtual memory. As using virtual memory, space for other programs can be saved. Sometimes bulky programs also do exist that cannot be stored in physical memory. So, virtual memory is utilized in order to execute large programs. This mode is used in 8286 so that in case of memory failure in real address mode, it can stay in protected manner. Let me tell you what is virtual memory. Virtual memory is the part of hard disk which can be utilized for storing large instructions inside the system. This external memory can be addressed by the computer other than the physical memory. When there exists an instruction that is to be loaded in the memory but whose size is greater than the provided physical memory, then some part of hard disk is used in order to store that instruction, which is known as virtual memory. The diagram here shows the difference between 8085, 86 and 286 architecture. In 8086, the architecture is being divided into execution unit and bus interface unit. But in 8286, the architecture is being divided into 4 units. One is nothing but of execution unit and bus interface unit, as similar to that of 8086. In addition to it, it has a address unit and instruction unit. The internal block diagram of 8286 microprocessor is depicted in the figure. The central processing unit of 8286 microprocessor consists of 4 functional units such as address unit, bus unit, address unit, bus unit, instruction unit and execution unit. Let us discuss in detail about each unit and its functions. Address unit. The address unit is used to determine the physical address of the instructions and operands which are stored in the memory. The address unit computes the 20-bit physical address based on the contents of segment register and 16-bit offset, just like 8086. The address line derived by the address unit can be used to address different peripheral devices such as memory and I/O devices. This physical address computed by the address unit is sent to the bus unit of the CPU. Now let us discuss about the functions of bus unit. The bus unit interfaces the 8286 with memory and I/O devices. This processor has a 16-bit data bus, a 24-bit address bus and a control bus. The bus unit is responsible for performing all external bus operations. This unit consists of latches and drives for the address bus, which transmit the physical address A19 to A0. The A19 to A0 facilitates all memory and I/O devices for read and write operations. The bus unit is used to fetch instruction bytes from the memory. Generally, the instructions are fetched in advance and stored in a queue for faster execution of the instructions. This concept is known as instruction pipelining. Hence, to fetch instruction, the CPU will not wait till the completion of execution of the previous instructions. While one instruction is being executed, the subsequent instruction is to be prefetched, decoded and kept ready for execution. The prefetcher module in the bus unit performs this task of prefetching. The bus unit has a bus control module which controls the prefetcher module. The fetched instructions are arranged in a 6-byte prefetch queue. In this way, the CPU prefetches the instructions to enhance the speed of the execution. Next, we will discuss about the instruction unit. The 6-byte prefetch queue forwards the instruction sequence to the instruction unit. The instruction unit receives instruction from the prefetch queue and an instruction decoder decodes them one by one. The decoded instructions are latched in onto the decoded instruction queue. The instruction unit decodes maximum 3 prefetched instructions and load them into decoded instruction queue for execution by execution unit. Let us now discuss about the functions of execution unit. The output of the decoded instruction queue is fed to the control circuit of the execution unit. This unit is responsible for executing the instructions received from the decoded instruction queue. The execution unit consists of the register banks, arithmetic and logic unit, and control block. The register bank is used for storing the data as a scratch pad. The register bank can also be used as special purpose registers. The ALU is the core of the execution unit and performs all the arithmetic and logical operations and sends the results either over the data bus or back to the register bank. The control block controls the overall operation of the execution unit. The 8286 CPU family consists of all the basic sets of registers, instructions and addressing modes of 8086. The 8286 processor is upward compatible with 8086, 8088 and 8186 CPU. In this section, operations of the registers are explained elaborately. The 8286 base architecture has 15 registers. These registers can be grouped into 4 categories as general purpose registers, segment registers, index, base and index registers, and status control registers. Let us discuss these registers one by one. Let us start our discussion with the general purpose data registers. 8 16-bit general purpose registers are used to store arithmetic and logical operands. 4 of these are AX, BX, CX and DX. Can be used either as 16-bit word or split into pairs of separate 8-bit registers as AHAL, BHBL, CHCL and DHDL. The AH and AL registers and this DH and DL register, AHAL and DHDL registers are used during multiplication, division and IO instructions. The CH register and CL register are used for loop, shift and repeat count operations. And this BH and BL register is being used as a base register as similar to that of the 8086 microprocessor. Let us now discuss about the segment registers. 4 16-bit special purpose registers are used to select the segment of the memory that are immediately addressed for code, CS for code, SS for stack, DS for data and ES for extra segment. The functions of this code, stack, data and extra segment registers are as similar to that of 8086 and we have discussed it in elaborate while we are discussing about the 8086 architecture. Now let us discuss about the status and control registers. 3 16-bit special purpose registers are used for record and control of 8286 processor. The instruction pointer contains the offset address of the next sequence instruction to be executed. Discuss about the flag registers or flag word description. The flag word register records the specific characteristics of the result of arithmetic and logical operations. The flag register bit D0, D2, D4, D6 and D11 are modified as per result of the execution of arithmetic and logical instruction. These are called status flag bits. Bit D8 and D9 controls the operation of 8286 within a given operating mode and these bits are called control flags. The flag register is a 16-bit register as shown in the figure and the flag register of 8286 and the functions of flag bits are explained now. CY carry flag, that is bit 0, set on higher order bit carry or borrow, cleared otherwise. Next, bit D2 parity flag, set if lower order 8 bit of result contains an even number of 1, cleared otherwise. AF auxiliary carry bit number D4, set on carry from or borrow to the lower order 4 bits of AL, cleared otherwise. Bit D6 0 flag, set if result is 0, cleared otherwise. Bit 7 sign flag, set equal to higher order bit of result, that is 0 if positive, 1 if negative. Bit D8 Let us discuss about bit D11 now because these bits are of status flags. Bit D11 overflow. Set if result is too large positive number or too small negative number to fit in the destination operand. Cleared otherwise. Now let us discuss about the control flags. Bit D8. Bit D8 is trap flag. Once set, a single step interrupt occurs after the next instruction execute. Trap flag is cleared by the single step instruction. Bit D9. Interrupt enable flag. When set, maskable interrupt will cause the CPU to transfer the control to an interrupt vector specified location. Bit D10. Direction flag causes string instruction to auto decrement the appropriate index register when set. Clearing DF causes auto increment. Next, bit D12 and D13. Bit D12 and D13 are input output privilege flags. Next, bit number 14. Bit number 14 is nothing but of nested task. Now let us discuss about bit 16, 17, 18 and 19 in the flag register. Bit 16 is nothing but of protection enable flag, places the 8286 in protected mode. When PE is set, this only can be cleared by resetting the CPU. Next, bit number D17. When MP is set, the monitor processor extension flag allows wait instruction to generate a processor extension not present in the exception. Bit D18. If EM is set, emulate processor extension flag causes a processor extension absent exception and permits the emulation of processor extension by CPU. Bit D19. When T is set, this flag indicates the next instruction using extension will generate exception 7, permitting the CPU to test whether the current processor extension is for the current task. Next, about machine status word. The machine status word consists of 4 flags such as PE, MP, ES and TS of the 4 lower order bit D6 to D19 of the upper word of the flag register. The LMSW and SMSW instructions are available in the instruction set of 80-86 and these instructions are used to read and write the MSW in the real addressing mode. That's all with the architecture of 8286 microprocessor. Let us discuss about the pin diagram of 8286 microprocessor in the next video. Thank you.